This video is identifying discrete and continuous functions. You should be on page 223. When you graph a function, it could consist of individual points, like the graph in example 3 on page 207. You might want to go back and stop the video and look at that right now. However, the graph of a function can also be part of a line or a line that has no breaks, like the graph in example 4 on page 217. You might want to stop the video and take a peek at that. Which gets us to the following key concept. So we have two different types of graphs when we're graphing lines. We have discrete functions, or discrete, and continuous. Now, a discrete function is individual points being plotted. That would be this example. A continuous function is a graph that is unbroken. It could be a straight line or a ray or a segment. So discrete is individual plotted points. A continuous function is I'll write it down here, a line, a ray, or a segment. Okay? Let's take a look at a problem here, and this is y equals 2x minus 1. They ask us to graph it with the given domain and then classify the function as discrete or continuous. So for part A, they said the domain is 0, 1, 2, 3. So if I made a table, and here's my function, y equals 2x minus 1, and we have our function 2x minus y equals 2x minus 1, my domain is 0, 1, 2, 3. Remember, here's my domain. My range is here. When I input 0, 2 times 0 minus 1 is negative 1. When I input 1, 2 times 1 is 2, minus 1 is 1. If I input 2, 2 times 2 is 4, minus 1, that's 3. And 2 times 3 is 6, minus 1 is 5. There would be my points, and I'm plotting them here. I'll just write them on here, 0, negative 1. I'll just darken them in, 1, 1. And I had 2, 3, and 3, 5. Do you see how this would be an example of a discrete function because it's individual points plotted? Now, if I did the same problem with this domain, this says I can use any number greater than 0. So, you know, all these points would still apply. I could still plug in 0 and get negative 1 and plug in 1 and 1 and 2, 3, 3, 5. So let me plot those again. But here's the difference. Not only are these points valid, I could have also plotted a half or 0.1. So I'm going to take my ruler out and I'm going to draw a ray starting at 0 for x, and it's going in the one direction forever. So let me get my ruler out, and I'm drawing this ray, and I'll put an arrow at the end. So this would be an example of a continuous graph. Now, as a general rule, and this is something I think you should get in your notes, as a general rule, you can tell if a function is continuous if you do not have to lift your pencil from the paper to draw it. Okay, like this is obviously continuous. I'm lifting my pencil, plotting a point, lifting it, plotting a point, lifting it, plotting a point. Here, I'm just drawing a ray. Okay, that's a little different situation. That would be continuous versus discrete. Okay. We also have, go down to here, we have real-world situations that can pop up that can either be continuous or discrete. Let's look at this example. Tell whether the function represented by the table is discrete or continuous. Explain. If it is continuous, graph it and find the value of y when x is 1.5. So they told us that we had a storm, rainstorm, and in an hour's time it dropped a ½ inch of rain. In 2 hours' time it dropped an inch of rain, and in 3 hours' time it dropped 1.5 inches of rain. So let me go ahead and plot those points. So when the storm started, there was no rain yet, so that'd be 0, 0. 1 hour later, there's a ½ inch of rain. 2 hours later, a full inch. and 3 hours later it was 1.5 inches. Now, the question is, are those the only points on this graph? Well, couldn't we have, instead of an hour, couldn't we have had 15 minutes of rain and found how much there was? Or could we have 1.5 hours of rain and find out how much there was? Well, sure there is. You could have those. So I'm going to take out my ruler and I'm going to draw a ray to represent all those other times that could be happening and the amount of rain that each could have. So this is definitely going to be continuous because I drew that ray. Okay? Here would be another simple example, just a real-world situation since we're addressing those. How can you tell? Think about buying gasoline. If you buy gas, and let's say 7-Eleven, it's probably $2 a gallon right now. Let's think about my table. I could buy no gas and pay no money. I could buy a gallon and pay $2. I could buy 2 gallons and pay $4. I could buy 3 gallons and pay $6. Imagine plotting those points. Okay, in fact, I'm going to do that. Here's the gallons I purchased, and here was the money I spent. So again, if I bought no gas, I paid nothing. If I bought a gallon, I paid $2. I said 2 gallons would be $4, and 3 gallons, $6. Now, could I buy a half gallon? Well, sure I could. Well, I'd have to plot that. Or could I buy 1.1 gallons? Well, sure. There's all these other points in between that I haven't plotted. Well, I need to take my ruler out, and I'm going to draw a ray then. The least gas I could buy is 0. And I could just keep on buying gas, keep on going. So here, this would have to be a continuous example. Buying gasoline at $2 a gallon would be a continuous example of a graph. All right. Now, let's say it wasn't gas. Let's say I was buying gallons of milk at Kroger. And milk's probably about $2 a gallon too. Now, this would be a little different situation. I could buy no milk and pay nothing. I could buy a gallon and pay $2, 2 gallons, 4, and 3, and 6. Now, when I go to that same graph, could I go to Kroger and take one of those gallons and dump part of it out and say, okay, I only want to buy a half a gallon of this? And the answer would be no. In fact, you'd probably get in trouble for doing it, right? You couldn't pour out part of it and say, I only want 3/4 of the gallon. They'd make you buy the full gallon. So the milk example, this would be a discrete example because you could only buy whole gallons. You couldn't buy quarters, fifths, or halves. So this would be an example of what that graph would look like. So that's the difference between a discrete function and a continuous function.